Welcome to this lesson. We are going to study vector 2 and we have a question here. I've tried to copy down the question and I believe we're going to understand my handwriting here. We are told that in the figure below, M divides OB in the ratio 1:2. So M is dividing vector OB in the ratio 1:2. So we have 1 and 2 proportions like that. We are told further that N divides AB in the ratio 1:2. Just a minute. M divides OB in the ratio 1:2 and N is dividing AB in the ratio 2:2. N divides AB in the ratio 2:3. 2:3. Then X is the intersection of AM and ON as shown. Then we are given further that OA equals to 2A. This is 2A vector. OM is vector B. Find in terms of A and B. So we are finding in terms of vector A and B the value of AB. Therefore, the value of AB, we can write a solution. Solution part A. We have from Roman 1. We want to get vector AB. So vector AB can be gotten through AO and we add OB. And this one must make us conclude that vector OA, since OA is 2A, then AO is the reverse, which means negative 2A, then plus. The proportions here are 1:2. So if this is one portion and it's a vector, one proportion and it's vector B, then this one will be 2B because we have two proportions of OM. So this will be 2B. In other words, OB is vector 3B, the whole of it, because we have B from A to O to M, and from M to B is two proportions. So that means we have 2B here, and the total of OB is going to be 3B. So we can rearrange this vector into 3 vector B minus 2 vector A. So that one is sorted. We can have the second vector, Roman 2. We are finding vector AM. AM, we can get AM through AO, then OM, in which case we will have the reverse again of OA, which means negative 2A, then plus vector B, which means we will obtain vector B less 2A. So that is the vector expressed in terms of A and B. Again, we have vector ON in Roman 3. Vector ON. So vector ON can be gotten through OA. Then we add AN, which means OA is going to be 2A as indicated, plus, for us to have this portion AN, then it is 2 out of a total of 5. So 2 out of 5 of vector AB, of the whole of AB, and AB has already been calculated here. So instead of writing AB, we can use 3B minus 2A. Then we open the bracket and we will have 2A plus, this one gives us 6 out of 5 vector B minus 4 out of 5 vector A. Therefore now we can group like terms together. 2 minus 4 over 5 gives us 1 and 1 over 5, and 1 and 1 over 5 is 6 out of 5. vector A, then plus 6 out of 5 vector B. So that is how we express the vectors in terms of A and B. It is very good. Now we get together to part B. Part B of the question gives us further instructions that AX, vector AX equals to H AM, and vector OX equals to K ON. Express OX in two ways and hence find the values of H and K. H and K are constants. So for us to find H and K, then we are going to express, as indicated here, OX in two ways. So part B, to express OX in two ways, we can have the first root of expressing OX being this which is already given here, which is K, then vector ON. And vector ON is what we've calculated here, 6 out of 5 vector A plus 6 out of 5 vector B, which means OA can be expressed as 6 out of 5 K vector A, then plus 6 out of 5 K vector B. This is one way of expressing vector OX. We can express vector OX in a second way. And now, in the second way, we must ensure that we accommodate the root having AX. So OX can be expressed using the root with AX, such that we can move from OA then AX. So we can have OM plus AX. With that, we will have gone from O to X. Therefore, now this is going to be 2A plus AX. And we are told AX equals to H multiplied by vector AM. And vector AM is here in Roman 2. AM is B minus 2A. Such that we will have 2A plus, this is going to be H vector B minus H, okay, we have a 2 here, so 2H minus H, we have a 2 here, vector A. So this must be noted as 2H. So we can now group the terms with vector A together in this expression, and the terms with vector A, are 2A then minus 2H vector A then plus H vector B, such that we can have vector A factored out, and we have 2 minus 2H, so vector A is factored out like that, then H vector B like that. So with this now, we can call this one the second way of expressing vector OX. And at this point now, we can now equate the coefficients of vector A in both expressions, such that from the first expression, vector A has a coefficient of 6 out of 5K, and in the second, vector A has 2 minus 2H, which means we can say 6 out of 5K is equal to 2 minus 2H. So we are equating the coefficients of vector A and the coefficients of vector A in the other expression. So which means now here we can simplify the equation by doing away with a fraction and multiplying by 5 through. Here we will remain with the 6K equals to 10 minus 10 vector H. And again, we can equate the coefficients of vector B in both expressions, such that here we will say 6 out of 5K equals to the coefficients of vector B is h. So here we can conclude that, okay, we have the equation more simple because h has been expressed as 6 out of 5. Okay, so we can solve this equation and this one using substitution method, whereby instead of h in equation 1 we can have 6 out of 5 k. So we can have 6k equals to 10 minus 10 instead of h, 6 out of 5k, such that after this step we're going to obtain a 6k equals to 10 minus, by 5 we'll get 1 and by 5 we'll get 2, such that this becomes 12, right? 12k. So now we can group like terms together and we will have 18k being equal to 10. If 18k equals to 10, it means k equals to 10 out of 18, which will be 5 out of 8. Sorry, when we simplify 10 over 18, then we're going to get by 2 5 and by 2 9, not 8, sorry. So k equals to 5 out of 9, which means if k equals to 5 out of 9, let me write it well, then we can get h according to this expression. H is going to be 6 out of 5 vector or constant k, which is 5 out of 9. This means we will have by 3 2 and by 3 3, by 5 1 5 1. So h can be simplified into 2 out of 3. So h equals to 2/3. So we've already determined the constants. I want to believe you're following keenly. Make sure you subscribe as we continue learning together. Now we have k and h, and that is part B solved. We can get into the part C, which says find the ratio of AM is to MX. AM is to MX. So AM is to MX, we can use this relationship here, which says AX is equal to H, and we have gotten H as 2 out of 3 of AM. So instead of H, we have it as 2 out of 3. So AX into AM equals to 2 out of 3. So if this is 2 out of 3, it means we have 2 portions and 1 portion here. So that we may say AX equals to 2 out of AM, which are 3 portions. Therefore, now we want to find ratio AM, which is 3 proportions. AM is to MX. So we will have AM is to MX expressed as 3 portions or 3 proportions into, we get backwards 1 proportion. So that means 3 is to -1 is the ratio. Thank you for following. Subscribe to this channel and share the link.